go. Hello, Algebra 2. How are you doing? This is week 3 and it's the second assignment. I hope you are doing well. On Tuesday, or in 3.1, whenever you watched that, we talked about, what did we talk about? Direct and inverse variation. And today we're going to continue looking at inverse variation since it is relatively new. And we're going to be able to write inverse variation equations from table of values or from story problems. So this is your little joke for today. Please have a laugh at home. Laugh. Make me feel validated. All right, let's go. I thought it was cute. Just a quick review what it means to be direct variation and inverse variation. We've got variables x and y. Direct variation says y equals a times x. And again, a was what we call a constant of variation of variation, and it was just a number, right? With inverse variation, same kind of stuff. There's a y, there's an a, and there's an x, but it looks a little bit different, okay? Direct is what we call linear, right? This is just a linear function. Inverse looked like y equals a divided by x, all right? So now you're taking that constant of variation a and dividing it by x, and this is what we're going to soon call a rational equation. Okay, so we're going to be working mostly with this right now. Let's take a look at a couple things. As I said, we're going to be able to look at a table of values and see if they vary directly or inversely, and we're going to be able to write a function for them. So I have a table of values. I've got some values for x and some values of y that are related, and I'm asking you the first question: is this varying inversely or directly? Let's just kind of take a look up here real quick. Again, with direct, there was some sort of constant variation that I multiply x by in order to get y. So let's just take a look at this first pairing, right? This 12 and the 6. There should be, if it's supposedly direct variation, there should be a constant of variation that I multiply x by in order to get my y value, right? And in this first pair, well, I know that 2 times 6 equals 12. Let's see if that times 6 holds for the rest of things, right? 4 times 6 is not 6. 6 times 6 is not 4. Okay, so I can kind of already throw out direct. So it's definitely not direct. Would it be inverse? Okay, so up here, I have this inverse. Sorry, I had to cut there. We are looking at inverse variation, right? With this inverse variation, I have y equals a divided by x. If I have to fiddle around with this inverse formula, right? If I'm going to fiddle around with it, what I'm going to do is I'm just going to multiply by x on both sides, because I'm going to do this for here in just a second. So that means that x times y equals, well, those cancel each other out. I'm just left with this constant of variation a, right? So over here in direct, we saw that y equals a times x. Over here, we see that my variables, if I multiply my variables together, then I should get some sort of constant. So let's check and see if that holds with this table of values. Again, if I multiply my x and my y together, if I multiply those, I should get some sort of constant here. So if I multiply 2 times 12, well, 2 times 12 is 24. Let's see if that holds for the rest of them. 4 times 6, 24. 6 times 4 is still 24. 3 times 8, yep, 24. It's looking like this does vary inversely. So can we write an equation for this? Well, I already know what my a value is because it has to be this 24 that we found. Again, that just kind of follows from this equation right here. So I could, if I want, I could say my x value times my y value has to be equal to 24. And I mean, that's my equation right here, right? X times y equals 24. And if I want to put it in this original form here, I could just divide by x on both sides. Divide by x on both sides. And say y equals 24 over x. And that would be my equation. I have my constant of variation on the top. I have my x value on the bottom, and it's equal to y. So this set of values I found by multiplying my x and my y's together and getting a constant, I found that this was inverse variation, and I was able to put this to a formula for an inverse function. Let's move on. Okay, I'm just going over some examples. Number of hours H it takes for a block of ice to melt varies inversely. So here we're already told that these variables vary inversely. So I know I'm going to have to be using some sort of y equals a over x, right? I'm just going to write that out. Varies inversely as the temperature T. So there is, whoops, there's one of my variables T. Oh, and we also had a variable H over there. I skipped it. If it takes 2 hours, so I'm going to highlight that. If it takes 2 hours for a square inch of ice to melt at 65 degrees, again, these kind of correspond with our variables of temperature and hours. Find the constant of proportionality is just asking, find this constant of variation, this value of A that we've been looking for, right? So, and also, I have one of these, I don't know if anyone's a Doctor Who fan, but I have one of those ice blocks that makes TARDISes and Daleks. It's pretty dang cool. Anyway, I'm a cool kid. All right. Here we go. So it doesn't really matter what I use for y and x, because again, they vary inversely. They multiply together to be a constant of variation. I'm just going to put this as points. I'm going to write points of temperature and hours, because to me, it just makes sense if my temperature in the room affects, is it A or affects? I don't know. So the temperature in the room is going to affect the time it takes for my ice cubes to melt. So I'm just going to write them as points like this, and I'm already given this point of 65 degrees for 2 hours. Okay, so we already have this point of 65 and 2. I know that these vary inversely. So, just like what we did in 3.1, this is very similar. Now we're just adding it to a word problem. I can find an equation that is going to represent this situation here, an inverse equation. So I'm going to put these variables here. I'm going to say if this is like my x and this is my y, I'm going to say that my temperature, or I'm sorry, my hours equals some sort of constant of variation divided by, again, divided by like my x, which in this case is my temperature, okay? So this equation here, hours equals my constant of variation divided by temperature. Now I can plug in this point that I just wrote. I can plug in that point into that equation in order to solve for A. So I have temperature of 65 degrees, and I have hours, 2 hours, so I'm going to say 2 equals A over 65 degrees. And now we can just solve for A, which is just a simple, let me just multiply by 65 on both sides real quick. Okay, and then that's going to cancel out. I'm just left with A equals 65 times 2 is going to give you 130. So now I have that A value. I can write that into my function here and say, I've got H equals A over, oh, not A over T, we just solved for A. H equals 130 over T, and that would be my equation to represent this inverse situation with our ice blocks melting. Okay, let's move on to the last one that I have. I say, take a second, pause. I would just read through this real quick. And I also have data points, all right? So basically we're asking, does the cross-sectional area vary inversely with water speed? And water speed is represented as velocity, right? So over here with this data point, I have a whole bunch of points at 4 points, or at 4 spots in my water draining out of the faucet here. I have a point with data that says velocity of 3 feet per second, an area of 0.75 inches squared. So I'm just going to take all of these and plug them into like a table of values just to organize it so it's out of the picture. So with this first point, I have a velocity of 3, and I have an area of 0.79 inches squared. And then I have 6.4 and 0.37. That's the second point. The next point here 8.5, 0.28, 10.2, and 0.23. So I have to determine, do these vary inversely? And we talked about varying inversely again. It would mean if my x and my y, if my two variables, if they multiply to be a constant all the way through these points, right? So to check, I'm just going to multiply all these points together and see if I get a number that is the same through all of them. So I'm going to say 3 times 0.79, okay? And that's going to give you a number of 2.37. What about 6.4 times 0.37? Well, that gets you 2.368. I have done these calculations already. 8.5 times 0.28, that gets you 2.38. And then the last one multiplied together, the 10.2 times the 0.23, that gets you 2.346. Okay, they're not all the same number, but again, this is kind of like a real life situation, so they're not going to be perfect, but they are very, very close. If I round all of these, it's roughly 2.4, right? So this A value, if I have my velocity times my area, I should get this A value, or this constant of variation, that's roughly 2.4. All right, so that's going to be my constant of variation. I'm going to use that, and now I can see. All right, let's just go back to this. I can say, yes, they do. Yes, they do vary inversely. And on your homework, I'm going to ask you to explain. You could just say, well, I multiplied all of my data points together, and they came up with a constant number. All right, so back over here, I'm going to say multiplying V and A got me a, oh, that's not proper English, but that's fine, got me a constant of 2.4, all right? So we know we have this constant of 2.4, all of those data points, you multiplied the x and the y, I multiplied the velocity and the area together, and I got a constant of about 2.4, so yes, these do vary inversely. If I wanted to write an equation, I'm going to switch over to, let's go blue. If I want to write an equation, I know that these two have to be inverse. So, and again, what did we just do? We just did velocity times my area, my cross-sectional area, equaled about 2.4. Let's just divide by one of our variables and solve for one of them. I'm going to solve for A, so I'm going to divide by V on both sides. That cancels out. And I'm just left with A equals 2.4 over V. Again, we could do the same thing if I wanted to do, not 2.5, 2.4. If I wanted to solve for V, I could just divide by A on both sides. And then I'm going to have V equals 2.4 over A. It's the same thing, right? Okay, so we were able to find if it was varying inversely, we were able to write a inverse equation that models the relationship. And the last question is, find the cross-sectional area when the water speed is 5 feet per second. Okay, so now we are given some sort of velocity, and I'm asking for, what's the area? What's the cross-sectional area? So what is A when velocity equals 5? Okay, so now I can just use these here. And I'm going to use this one. I'm going to use this first equation because that just makes sense. I know what my velocity is. I'm trying to solve for my area. So I'm going to plug in here. I know my velocity equals 5. I'm trying to find what my area is. So area equals 2.4 divided by my velocity of 5 feet per second. And then area is going to be equal to 0.48. So 2.4 divided by 5 gets you 0.48 inches squared, okay? It's the same stuff that we did in the assignment and in the video of 3.1, but now we're just kind of putting it to word problems, putting it to table of values that you may see in the real world. Anyway, that's what we did, all right? One of these, it's going to be very similar to your homework, and there's going to be 2 questions that are also very similar to this one here, okay? So again, if you want to check that something varies inversely, just multiply your values together and see if there's a constant of variation through all of them, right? Okay, and if you know that they vary inversely, plug in a point that you know from the problem, solve for A, and then be able to write an equation from it. Please let me know if you have any questions. Otherwise, I think you guys are doing a great job. Keep up the good work. Let me know if you have questions, and I will talk to you later. Oh, wait, I did have the homework. Where'd the homework go? The homework. Oh, wait, the homework. The homework. 3.2. Page 328, numbers 4 and part A, B of 4, 5, and then number 21, part A, B. Again, I have it all typed up on the Google Doc if that would be easier, or if you want to do it by hand, totally works. Have a great day. Adios.